so this is a Unit 14 seminar, Introduction to Sine Curves, and we're also going to deal with cosine curves. So basically, we are taking the concepts that we learned in Unit 11, 10 and 11, basically the concept of functions, transformations of functions, and we're applying it to trigonometric functions. So even though there's also a tan curve, this unit guide we're really focusing on sine and cosine. And I want to go through some terminology first of all with you. So first of all, what do we mean by periodic functions? Those are functions that repeat itself in values or patterns in regular intervals or periods. So the sine function will continue in regular periods, and the original sine function has a cycle that starts at 0 and goes to 2 pi. Cosine function as well starts at 0 and goes to 2 pi. That's how long it takes for the original function to complete one full cycle. Now notice we're on the x-axis, we're measuring in terms of radians. I'm going to be talking about radians a lot in Unit 15, but they're basically a way of expressing degrees. You may remember that I always tell you when you're doing trigonometry to switch to degree mode. Well, sometimes in this unit you're going to want radian mode. And pi does not represent 3.14 anymore. In the world of trigonometry, pi means 180 degrees. So when I say pi divided by 2, I actually mean 180 divided by 2. Pi by itself is 180 degrees. 3 times pi divided by 2 is 3 times 180 divided by 2 is 270 degrees, and so on. But just like when we were talking about regular functions, we have a few key points that you're going to have to memorize that we're going to talk about in the next slide. And you may notice that the cosine function, so this is actually the graph y is equal to sine x, and this is the graph of y is equal to cosine of x. And if we cover just from 0 to 90 degrees, to the left, or actually, if I continue this graph by another 90 degrees this way, so let's say negative pi over 2, negative 90 degrees, right? So if I just extend it by that amount, you'll notice that the sine and the cosine function look exactly the same. And let's just ignore this part. And the reason for that is that the cosine function is a phase shift left by pi over 2 units. So if I'm shifting to the left by pi over 2 units of y is equal to sine x. That's a very key characteristic that not a lot of people recognize. So cos x is a phase shift left of y is equal to sine x. So that's the sine x function, cosine function, and that's a characteristic. So if you ever forget to draw how to draw the cosine function, basically just at 90 degrees, draw your axis here and cover this part, and you have your cosine graph. Okay? So that if you know how to draw the sine graph, you also know how to draw the cosine graph. Now, I'm giving you a table of values for basically the key points in terms of radians. So you'll notice that, why is everything running so slow? So I want you to copy down this chart because you don't have it in your unit guide. And degrees is the measure that you guys are used to. 0, 30, 60, 45, 90, 180, 270. Now in the world of trigonometry, we're going to express things in terms of radians. So it's really good to memorize this chart. Memorize that 30 degrees is pi over 6. 90 degrees is pi over 2. Those are important key points. I'm just going to erase this so you can copy it. Now, it's not necessary to really memorize every single point on this chart. There are some main ones. So when I think about the sine function, at 0, 0, that's an important point. At 30 degrees is another important point. At 90 degrees, at 180 degrees, 270, and 360. So really, I would just memorize those 6 key points. For the cosine function, I would memorize, just kind of ignore the radical numbers, these main points. And the reason why these points are important, these are the points you're going to apply transformations to. Just like you applied transformations to the quadratic function y is equal to x squared, the cubic function, the square root function, you're also going to apply transformations to the sine and cosine function. Tangent function is important as well, but there are asymptotes at the tangent function. So at 90 degrees and at 270 degrees, we have an asymptote. I'm going to talk about that more in the Unit 15 seminar or in a separate pencast. We're not going to focus on the tangent function today. Now, I believe there's a part in your unit guide when you're going to be asked to convert from degrees to radians or vice versa. So let's do an example. If I had the question, or 150 degrees, and I was asked to convert into radian mode. So basically, you would always take whatever your degree measure is, and you are going to multiply it by pi over 180. Pi over 180. This is to convert from degrees into radian mode. So I know that right away, well, if we divide by, let's say, 3, for example, or if we divide by 30, I know that it goes into this number 5 times. 30 times 5 is 150, and 30 times 8 is 180. But you can break it down. First, you can divide by 10, and then you can keep going until you get into your lowest common multiple. So because I'm putting 150 degrees over 1, basically you have 5 pi. Oh, sorry, not by 8. My mistake. This should be a 6. 30 goes into 180 6 times. So we have 5 pi over 6, because 3 times 6 is 18. So that's the main way to convert from degrees to radians. If I wanted to do the opposite, so if I wanted to take 5 pi over 6, and I want to figure out how much that is in terms of degrees, well, you can just do 5 times 180 divided by 6, and that will give you your answer. Or you can do the opposite, which would be 180. Basically, what you're doing is 180 divided by pi. You're using the reciprocal of this because the pi's cancel out. Pi time and this pi cancel out. So you essentially have 5 times 180 divided by 6, which would give me 150 degrees. So the formula, from degrees to radians, you always multiply by pi over 180, and from radians to degrees is 180 divided by pi. That's the formula you use. So simple stuff. It makes sure when you're doing your test, you show all of your steps. Okay, so now we're going to talk about different parts of a trigonometric equation. Sometimes they're called sinusodial functions in your textbook, but they mean the same thing. So this is a typical sine curve, but sometimes what you're going to find, there are numbers instead of degrees.